Hello and welcome to another one of these ADD videos. Today we're going to be talking about particular solutions to higher order non-homogeneous differential equations. In other words, we got something like this, but instead of equaling 0 like we did before homogeneous equations, it's equal to some functions. What are we going to do? What are the steps? Step 1 is to find the characteristic equation and solve for R. And this would be of the homogeneous. So as if it was equal to 0. And you should have already encountered many types of these problems. And then after you find that, you're going to check for repeated roots. What do I mean by that? Well, I mean that your homogeneous solution should not look anything like what's on the right hand side of the equal sign right there. If it does, then you're going to have to multiply by an equation. Either, an AT plus B or AT squared plus BT plus C, just depending on what the scenario is, and I'll show you an example, okay? But if it's not a repeated root, then what you do is you come up with a general particular solution in which you don't use the coefficients, but you mimic the pattern of FT, sorry. So mimic FT, but use a general constant. Okay, so what do I mean by that? I mean, for instance, if your f of t was equal to, excuse me, I just went outside and I think some pollen or something is irritating my nose. So if f of t equals e to the 3e to the 2t, your proposed particular solution should be a e to the 2t, sorry, not bt. Or if f of t, for instance, is sine of 4t, your particular solution should be sine of 4t plus cosine of 4t. I would put an a there and a b there. Why would I have cosine even though it wasn't part of sine? If you remember your imaginary solutions to your characteristic equation has e to the alpha t sine plus e to the alpha t cosine beta t. Alright, so you got to include them both. So that's enough little examples. I'll show you more concrete problems here in a second, or in a different video if you watch the example video. But here we have, after we find that, we're going to take the derivatives, take successive derivatives, depending on your differential equation. Successive. On y of p, then you're going to plug into your differential equation and you're going to simplify. Once it's simplified all the way down, you're going to equate both sides coefficients. And solve for the constants. finally, what you're going to end up doing is you're going to come up with your general solution. It's going to be y equals the homogeneous solution plus the particular solution. Now, in some of the more complex problems, you'll have to do multiple particular solutions, and then you can use what's called the superposition principle. There'll be a video dedicated to that specifically. But these are the steps that you will need for solving for the particular solution. So we're going to illustrate that in the example video next. Make sure you check that out. But basically, find your characteristic equation of the homogeneous solution, check for repeated roots, come up with a general solution or your general particular solution, take the derivatives, plug into your original differential equation, okay, and then simplify, set the coefficients equal to each other, and solve. Alright, so check out the example video. Practice, practice, practice. Thank you, and have a nice day.